said to him, I was like, all right, let's meet. We met up Monday after school, and we just cranked out a lesson. You know, the MEPs and the mini lesson was all Zahid. So.
Because the thing about teaching is that you're not teaching them things, you're teaching them how to think about things.
Yes.
Well, first and foremost, I felt really cool, right? Because I was being taught things that, I was being taught sort of things that I wasn't supposed to know yet. Right? In all the MEPs that she gave before, I noticed a pattern. And that is that she teaches you things that you're more or less supposed to know by then already, right? Because that's why there are multiple entry points. You're sort of, one and done. And they're sort of things that you want to keep in the back of your head while you're doing the mini lesson, which is the way I structure is that one is product rule and quotient rule. Those are things that are basic knowledge, and it hints them towards something that they're not. I didn't expect them to quite get it with the first one because it's sort of very vague what I'm hinting them towards. But I wanted to make sure they had the two rules in front of them, because number 3 is how do these rules work conceptually. Number 2 is just a practice problem, just get their feet wet. And number 3 is how do the product rule and quotient rule work on a conceptual level, because it works in the same way as the chain rule, which is you take derivatives separately and then put them together in some way, shape, or form to find your final answer. The cool thing I learned from this, right, is that Ms. Rahman in this situation, right, didn't just teach me the thing or how to think about the thing. She taught me how to think about the thing. Let me explain. If she had just taught me the thing, she would teach me the problem, how to solve it. I wouldn't be able to solve any other problem. If she had taught me how to think about the thing, she would have taught me, for example, the chain rule and maybe sort of a vague idea of where the chain rule comes from, right? That way I can deal with any sort of chain rule problem. But if I wanted to learn something completely new, I don't know, integrals or something, I wouldn't be able to pick that up on my own without some level of teaching. But that's where this sort of third layer comes in. By learning from her how exactly she goes about the MEPs, establishing this basic idea, and then a problem to sort of get warmed up, and then something that kind of, but not really, leads you on to the actual lesson. That's, for example, something I can apply to anything in or out of math. Let's say, take integrals in math, for example. I could say, well, integrals kind of, sort of look like derivatives, more or less. So I can keep that background idea of how derivatives work, and then I can sort of start thinking about integrals, and then I would be able to teach myself it from nothing, from scratch.
Yes.
Something that surprised me on the positive is that in this particular situation, these are classmates who I've known for years and years now. These are people who are sort of like family to me. I know, or at least have a vague idea of how it is that they think. So I was able to sort of phrase things a certain way or show things a certain way that would lead them to think in the way that I want them to think. If this were, say, a classroom of completely new students, I don't know how these students sort of function. I don't know each of their styles. I can't necessarily build a lesson that caters to them. But because this is essentially, I'm teaching my extended family here, I know more what I'm doing. As for things on the negative, I can't say that there's anything definitely negative, right? But there's something that is both positive and negative. Even though with these students who I knew very well, I was able to predict and sort of direct their thinking more or less, it wasn't perfect. For example, there would be some times where I'd introduce something. I would get sort of halfway through the chain rule. I wouldn't introduce it as the chain rule yet. I would introduce it as sort of, let's try these things. And they would get to something and I would ask, okay, so now what do we do? And to me and to Ms. Rahman, for example, it would seem obvious because we know the chain rule, we know how it operates. But they don't, so I can't always assume that they will think in the same way that I do. So sometimes I would sort of lead the class onto something, see, okay, so now this is similar to, and then I hear silence. So I had to sort of learn how to make things explicit, but not front load, because I wanted to make things explicit in the sense that they'll get the idea that I want them to get. But also I don't want to front load because I want to teach them how to think about the thing. I want to have them arrive more or less to the conclusion on their own.
The planning, I was super psyched that he was super psyched, so it just worked out well. One of the things that I observed that Zahid and I didn't even talk about, but something that he adapted to was when he did notice that his peers were struggling, when he was trying to make the connection of, okay, we apply the power rule, but we also apply the derivative on the inside of the function, when he was trying to get them through the chain rule. So they got the derivative on the inside, and he was like, okay, well, we have these two separate pieces, right? Tying back to his connection of, well, we separate things and we put them together, we combine them later. He was saying, oh, well, what operation are we going to do, right? We've seen this product rule and this quotient rule, and what are we going to do? And, his peers at first were like, addition, subtraction, it was like a game, like, say I'm right, But he adapted to that, and he just made something natural. He was like, oh, well, product rule, what do we use? Well, plus sign, all right? Well, quotient rule, what do we use? Minus sign. Oh, well, we use those, maybe there's some others. And then he was able to use Desmos. He didn't get to mention this, but he was able to use Desmos as a visual for them. He was like, okay, well, some of you guys saying plus. Well, let me put on Desmos what we have. We have the original function. I'm going to have Desmos calculate the derivative. Desmos has that functionality. And they say, okay, this is what it looks like. Then he plugs in the derivative that they got, and he was like, does this match? No? Well, then we got to fix it. Right? We're almost there. We have the pieces, but we got to fix it. So then it was just it was like a mini exploration in the exploration. So in that moment when he and them all made that connection together, they got it. So now we're going through the next days of lessons, and they're applying the chain rule properly. Like, overall, they took away the main point that he was trying to make, and that was great.
So
as a teacher, you adapt not just by sort of on the fly according to the situation, because Ms. Rahman mentioned the situation where I would have the exploration within the exploration. What if I told you that I had predicted that from the day before? Because as a teacher, you'd want to learn from previous experiences, but me, I didn't really have previous experiences teaching. So I took from, well, I know my friends. So I thought, well, if I want to get them to think through this on their own, probably going to get it wrong a few times. So I thought, okay, product rule, what do we use? Add. Quotient rule, what do you use? Minus. And then we take the remaining signs, right? Multiplication, oh, that works. I had also predicted that, for example, rather than multiply it at the end, they would just put the second derivative inside the first one. Mm-hmm. And I thought, well, if I were looking at this, and I am one of them, right, I would probably make this mistake. So, but say you didn't necessarily know your students, right? Say you were a fresh teacher, you would still want to try and learn the way that your students like to think. That way you can predict where they'll trip, and instead of having them trip and then keep going, have them actually just jump over it altogether. Yeah. But the common misconceptions that they would make with me knowing how they would think, yes, well, those are the conceptions that are more sort of pertinent to the situation.
Yes.
If they got it right the first time, I'm not going to say, well, I thought you were going to make this mistake.
Right.
Show you. I would give them another problem and have them work through it. And then maybe, right, if I'm still not completely sure, a third. I would have them work through multiple examples to see if those mistakes do come up. Because if they don't come up at all, then they don't need me to teach them the mistakes because they're not there. But I can't just assume if the mistakes don't appear in the first one that they won't appear in the second or third. And that's why in the mini lesson I had two situations. Because if they got the first one first try, let's see if they get this first try. And if they get both, then they got it. There's no need for me to say, well, you could have done this wrong.
Honestly, I gotta give credit to Ms. Rahman, because if you learned how to develop thinking because you've had your thinking developed in that way because of your teacher, then both of you have done an amazing job to get to that point. I mean that and there it is. That is learning and teaching and learning. It's not